Hypothesis testing for the equality of two population mean. This is a general technique and it can be extended into two major categories. One of them is if we have two populations and the samples are selecting independently. So we call it as independent sample. Or second case is we have dependent sample. These are the two broad categories. Independent samples, dependent samples. Independent sample is further bifurcated into two segments. One of them is population standard deviation norm, sigma 1, sigma 2, known. Population standard deviations are known. We can use Z statistics. If population standard deviations are unknown, sigma 1, sigma 2 unknown, then we can have further two procedures. These two procedures are known as, these are the T procedures, T statistics. These two procedures are further split into two segments. One of them is known as pool t-test. And other of them is called non-pool t-test. And this dependent sample t-test is known as paired sample t-test. Paired sample t-test. In the procedure booklet, this is the procedure T3, this is T4, this is T5, and this is T6. So this is labeled as T3, this is labeled as T4, T5, and T6. Procedure T3 is known as independent sample Z test. Procedure T4 is known as independent sample t-test. It is described whenever the population standard deviations which are unknown but assumed to be equal. So we have a criteria of sigma 1 is equal sigma 2. Population standard deviations are assumed to be equal. And if population standard deviations are assumed to be unequal, so we have another test which is named as non-pool t-test. Sigma 1 is not equal to sigma 2. This is T5. And T6 is a case where the samples are dependent. This type of test is generally used for repeated measures or the scenarios which are repeated on the different segments of time. For example, the sugar patients are taking medicines. Before medicines, what is the level of sugars, and after taking 1 week medicines, what is the level of sugars? So we have participants. X1 is a level of sugar before taking medicine of the same patient, and X2 is the level of sugar after taking medicine. So these pre-taking medicine and post-taking medicine, these type of scenarios are to be solved by using paired sample t-test. In this entire chapter, we have a null hypothesis like this: H naught population mean 1 is same as population mean 2. This is the general hypothesis for this chapter. So whatever procedure we are using, the hypothesis remains same. Either T3, T4, T5, T6, the hypothesis remains same. This hypothesis can also be written as H naught mean 1 minus mean 2 is equal to 0. We can extend this concept to some differences. Like this hypothesis may be in a way that the mean 1 and mean 2 have a difference of 6. If this number is described as 6, so we have update some formulas in the z-test and the t-test versions. Uh, Other examples of paired sample t-test is like we have observations of students when the student took admission in the preparation setup, like preparing a GRE. So at the time of admission, the score of GRE of the student, and after 1 month preparation, the score of the same student in the GRE test. This is known as a mock test, the result of mock test, and this is the result of after 1 month preparation of the same student. Similarly, we have a second student, the result of the student before preparation, and this is the score of the same student after 1 month preparation. In what we are interested? We are interested that the mean 1 is equal to mean 2, or alternative is test preparation center is claiming that the mean will be significantly larger after 1 month preparation. The mean 2 is what? The average of average marks by student in GRE is significantly larger than the result at the mock time. So this is basically, that may also be described as difference is some number. Like suppose the testing center is claiming that the difference is 10 points, or the difference is 20 points. So if the statement is described in this way, that the difference will be equal to the 10 points, then null hypothesis will be what? Mean 1 minus mean 2 is equal to 10, and mean 1 minus mean 2 is not equal to 10. That will be the null and alternate hypothesis. And what are the independent samples? Independent samples are those samples in which we have one item is not related to the another item. Like suppose we have male here in a company, the salaries of male, I am representing it as salaries and male, and the salaries of female. So we have one male, second male, third male, last male. Suppose there are the 100 males in the company and there are 20 females in the company. And what we are interested to observe that the average salary of male and female are same in the company. Because these males and females are not related to each other, and that is not a paired observations. That is why we can say that the the participants are independent and the salaries are independent, and we take the advantage of these procedure, either T3, T4 or T5, depending on the situation. If the sigmas are known, we can apply T3, which is Z test. Z test is described as x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by sigma 1 square upon n1. This is the standard error of population from population 1. This is the standard error from population 2. Sigma 2 square upon n2 in the square root of this. This is called the Z statistics, which is known as T3. In this Z statistics, if the hypothesis is mu1 minus mu2 is 0, then you can place this factor to 0, the formula reduced to only x bar 1 minus x bar 2 divided by this standard error. So that will be the reduced formula if we are testing this hypothesis as 0. If we are testing the hypothesis that the difference between the two means is 10 point, as I was telling you about the case of preparation of the GRE. So in that case, this number will be 10 because the difference of the population mean in the hypothesis stated it is stated that it is 10. So this is the scenario which we have to further proceed, and in the next slide I will describe procedure T4 because procedure T3 is already described in this presentation. Procedure T4. To perform the hypothesis to compare the two population means. So H0 is mean 1 is same as mean 2. This is the null hypothesis. We can change the hypothesis like mu1 minus mu2 is equal to 0, or we can write down this if the number is specified that the mu1 minus mu2 is equal to some number which is described in the hypothesis. Alternate may be not equal to, alternate may be less than, mean 1 is less than mean 2, mean 1 is greater than mean 2. As I was telling you that the test preparation center is claiming that the average score in GRE will be significantly larger after preparation as compared to at the time of mock. So we have a hypothesis, alternate hypothesis like this. If we are considering a case of Slimming Center, the participants took admission in a Slimming Center. At the time of admission, the weight of the candidate, and after 1 month therapy, the weight of the same candidates. And the Fleming Center is claiming that after 1 month therapy, the average value would be reduced significantly. That mean 2 is smaller than the mean 1. But this is not the situation of the paired t-test. I am just giving you the two examples here just to explain these two real life hypotheses in the situation. Second step is same. You have to describe the level of significance. Step number 3, compute the value of T statistics. In the T statistics, we have SP here. SP is what? SP is the pooled estimate of population standard deviation. That is why it is called pooled t-test. Pooled estimate. Pooled means what? Pooled estimate of sigma 1 and sigma 2. Sigma population standard deviation. Pooled, why it is pooled? It is a sample standard variance 1, it is the sample variance 2, and we are pooling these two variances by a combined variance formula. So we are just weighted, we are taking the weighted mean of the two variances here. This is called standard deviation pooled. This standard deviation pool is to be plugged in here. And if I generalize the formula like from the Z distribution, that it will be mean 1 minus mean 2 minus population mean 1 minus mean 2 divided by sigma 1 square upon n1, sigma 2 square upon n2, square root of this. As in the assumption, equal variance is assumed. Equal standard deviation means was sigma 1 population standard deviation 1 is equal to the population standard deviation 2. So if we are taking these two standard deviations same, so sigma 1 square and sigma 2 square are same, and I took sigma as common. If I took sigma as common, so I have sigma 1 square removed from here, sigma 2 square removed from here, and sigma square under root, that is sigma. So I do not have any sigma in this situation because sigma are unknown. So we want to put a estimate of sigma. That estimate of sigma is this. So that is why we have a SP here in the formula. The under root 1 upon n1, this is 1 upon n1 and 1 upon n2. These two numbers are here. We compute the T statistics. This is called T observed by pool T test. Fourth step and is same. Either we can construct a critical region or we can have a p-value. If p-value is less than equal to alpha, then reject H naught. The same criteria we have. Finally, we have to interpret the result. So this procedure is called pooled t-test. Assumptions of the pooled t-test are what? Your sample must be randomly chosen. The samples are independent, means they does not have any relationship among themselves like paired t-test. Normal populations or the large samples. Your populations are large, your samples are large or your populations are normal. So these are the different conditions. And the last condition, which is very important for specific for the pool t-test, your standard deviations are same. If your standard deviations are same, you can have this pool t-test. You can use this pool t-test. The reduced formula will be what? Reduced formula will be you can put this as 0 because you are assuming that the population means are same in the null hypothesis. This is reduced to the 0, the x bar 1 minus x bar 2. These sigma will be taken as common like as sigma, and sigma is unknown. So we have to put an estimate. This estimate is a nothing other than the um, combined variance. Combined variance or weighted combined variance by the weighted technique. In this example, American Association of University Professor conduct salary studies of the college professors and publish its finding in the annual report. We want to decide whether the mean salaries of the college faculty in the private and the public institutions are different. Pose the problem as a hypothesis test. The, the average salary of the faculty in the private colleges and the average salary in the public institutions. So whether these two salaries are equal on the average or not for all professors. H naught will be what? H naught will be they are same. Mu1 is the average salary of all professors in private colleges is same as average salaries of all professors teaching in a public institutions. They are same, and we have to check whether the salaries of the are different. H1 will be what? H1 will be the two salaries are not same. Mean 1 is not equal to mean 2. So we first have to look at whether the two samples or the two populations we have are independent population or we have a dependent population or we have a different population, either we have a same population. So clearly it is private teachers are separate and the public institutions, teachers who are teaching in public institutions are entirely different. So these are the cases of independent sample. So you can assume that either T3, T4, or T5, any one of these three procedure can be used here, depending on the other assumptions. You have to explain the basic idea of carrying out the hypothesis test. The hypothesis test is independent sample test. Independent sample, either Z test or pooled or non-pooled T test. We have to check either one of these three by looking at the sample. Suppose 35 faculty member from the public private institution and 30, that's the different sample size. This is N1, sample size 1. This is sample size 2. And random samples. Randomly, assumption number 1 is fulfilled. Independently, independent sample, other assumption is fulfilled. So these two assumptions are given in the problem. That what are the assumption? Assumption number one is random sample. Assumption number 2 is independent sample. So assumption number 1 it is. Assumption number 2 it is independent sample. Now we have to check assumption number 3 and 4. Select their salaries as shown in table number 10.3. You have to test the hypothesis. The alpha is given here. Alpha is 5%. So these are the salaries. Private institutions, sample 1. Public institutions, sample 2. We have a 35 faculty member from the private institution and 30 samples from the public institution. The claim is not like that. Public teachers in public institutions are getting more salary as compared to the private institution. Neither it is stated that the private institution people teaching in private institution are getting the higher salary as compared to the public institution. We have to check whether the means are same or mean are not same. Assumption number 3 was populations are large. Sorry, the samples are large or the populations are normal. So it is not stated that the populations are normal. Nowhere is it stated that the populations are normal, but we have a sample size of 35 and sample size of 30. The sample sizes are large, so there is no need to check the normality. And even though we have to check some outliers, so we are constructing the normal probability plot for sample 1 as well as for sample 2, or the box plot for sample 1 and sample 2 for checking the outliers and normality. Samples are random. Assumption number 1 is fulfilled. You must have to check the assumption before implementing the procedure. Any procedure. Independent sample, it is stated in the problem. The samples are 30 and 35. Assumption number 3 is fulfilled because we have a large sample sizes. These descriptive measures are computed directly here. I'm providing you, but there is no there are some examples in the exam. There are some questions in the exam where this statistics will not be provided to you. The data will be given to you. You have to compute the sample mean, sample standard deviation yourself. But here I am providing, and because it is a solved problem, this information is given to you. This is known as descriptive measures. The descriptive measures is given to you. If the descriptive measure is not provided to you in the question, you have to calculate the descriptive measure yourself. Descriptive measures. This is the normal probability plot for sample 1. This is the normal probability plot. Both are looking as normal. Nowhere we have an outlier. So assumption number 3 is fulfilled. Population, both of the part of the assumption number 3 are fulfilled. Sample sizes are large as well as the standard population are normally distributed because these two graphs shown as a linear line. Assumption number 4 is what? Assumption number standard deviation are same. If the boxes are more or less have a same width, we can say that the standard deviations are same. This is one way of checking the assumption, standard deviation. If we have one box which is too wider and other box we have a very smaller, so clearly we can say that the standard deviations are not same. This is, I suppose this is the situation. So if we have a situation like this in the box plot, one box is too wider and one box is too smaller, so we can have a perception of standard deviations are not same. If that boxes are more or less having a same width like here, so we can have a perception of equal standard deviations in population. So this is the way of checking the assumption number 4. And another way of checking the assumption number 4 is to use the values of the sample standard deviations. The sample standard deviation 1 is of 26 and sample standard deviation 2 is of 23. There is a informal check of testing the equality of standard deviation, and that is what? That is, you can check this by taking a ratio of what is two standard deviation, standard deviation of one sample and standard deviation of another sample. Which sample is to be taken on the numerator and which is in denominator? There is no criteria, only one. Larger standard deviation will be in numerator and smaller standard deviation will be in denominator. The larger is 26.21 and it is 23.95. If this ratio is smaller than 2, if this ratio is smaller than 2, you can have assumption of uh, equal standard deviation. If it is smaller than 2, you have assumption of equal standard deviation. Sigma 1 is equal to sigma 2 is smaller than equal to 2 if true. Less than equal to 2, if the ratio is less than equal to 2, we have to assume the population standard deviations are same. If the ratio is greater than 2, we have to assume the population standard deviations are not same. So it is a very clear cut criteria and it is very simple. You have just to take the two sample standard deviation, put the larger standard deviation in numerator and smaller standard deviation in denominator, ratio of that. If the ratio is smaller than 2, you can assume the population standard deviation are same. Otherwise, you can assume the population standard deviation are not same. So this is the criteria that you have to use for adopting pooled or non-pooled. T4 is to be used in this scenario. T5 will be used in this scenario. So now you have a very clear-cut criteria of defining T4 and T5. T3 is used if the population standard deviations are known. T4, T5 are used if the population standard deviations are unknown. If the two population standard deviations which are unknown, if assumed to be equal, you can apply the pool t-test, which is T4. If the population standard deviation assumed to be unequal, you can apply procedure T5, which is known as non-pool t-test. This can also be taken and considered by using the box plot. If the box plots are same, like this, so we can assume this. So pool T test will be used, T4. If the box plots are like these, then you can assume population standard deviations are not same. You can apply T5. So T4 and T5 just based on the equality of the population standard deviation or inequality of the population standard deviation. In this problem, we have this situation of the box plot. which is quite realistic, and we can take an action of solving the hypothesis by T4, which is a pooled t-test. This ratio is also confirming that the pool t-test is appropriate because the ratio is smaller than 2 in this scenario. So we have to apply T4 to solve this problem. In T4, we first have to compute the pooled standard deviation of the estimate. Uh, Hypotheses are these, means are same. Mean one is what? Average salary of teachers working in the private institutions and the average salary of professors working in the public institution. The two, on the average, they have the same salary. On the average, they does not have the same salary. Alpha is already given to you in the problem T statistics. You can check. This is reduced formula because it is 0. Actual formula is this, but it is 0 because mean 1 is equal to the mean 2, that is 0. First, you have to compute this SP. SP is what? Is the pooled estimate of population standard deviation, which is unknown. So we have to calculate the weighted variance and take the square root of that weighted variance. So why I'm talking it as a weighted variance? Variance 1 plus variance 2 divided by 2. This is the weighted mean of unweighted mean of variances. I'm not interested in the unweighted mean of variances. I'm interested in the weighted mean. How it is weighted? Sample size 1 is to be used here. Degree of freedom 1. It is not sample size 1. It is degree of freedom 1. It is degree of freedom 2 and 2 minus 1 and divided by n1 minus 1 plus n2 minus 1. That is n1 plus n2 minus 2. N2 minus 2. This is called weighted variance, pooled variance. And standard deviation will be the square root of this. So this is 225.19. And I substituted this 25.19 here in this formula, and the remaining values are substituted. Sample mean 1, sample mean 2, these two numbers, and this is 25.19 SP. 1 upon under root and n1 plus 1 upon n2 under root. This is T statistics. We call it as T observed because this T statistics is obtained through sample. Now further we have two approaches in step number 4. Either we can apply the critical region approach or the p-value approach. 3 steps are completed here. Step number 1, null and alternate hypothesis. Step number 2, alpha, level of significance. Step number 3, t-test, which is pool t-test. And in step number 4, critical region. Step number 4, by critical region, and step number 4 by p-value. So by critical region, we have minus 1.96 because alpha is 0.05 and degree of freedom is nu. It is equal to n1 plus n2 minus 2. That is very important. N1 plus n2 minus 2. This is the formula of degree of freedom for the pool t-test. The degree of freedom 35 plus 30 minus 2, it is 63. The 63 degree of freedom and alpha by 2 is 0.05. So we have to obtain a number from the t table. This is t 0.05. 0.025, not 0.05, because alpha by 2 is to be used with the degrees of freedom 63. This number is minus 1.99. Minus 1.99 and plus 1.99. So these two values are known as the critical values. And my calculated value was 2.39. 2.39 is here on the right region. If the 2.39, which is the T observed value, is in the right side critical region, so we can conclude that mean 2 is larger than mean 1 because it is rejected from the right side. In step number 4, by p-value, you have to look up t statistics, t 0. T 0, 2.395. 2.395 is the value of the observed t statistics or the t-test. This is the observed value. And you have to search this value against the degrees of freedom 63 in the t-table and get a p-value, get a probability. That probability is called p-value. So how probability p-value is computed? In step number 3, you have computed the T observed. T observed is 2.395 against the 2.395 in the degree of freedom 63. Look up these two numbers into the T table and get a probability. That probability is 0. Is 0, 0.0, smaller than 0.02 or larger than 0.01. So if we are obtaining this p-value from the software, it is provided as 0.0196. If the p-value is smaller than alpha, we have to reject the null hypothesis, as we have 0.05, 0.01 is smaller than 0.05. If I'm comparing it by two-sided region, and that is 0.025, it is still smaller than that. So we can conclude that the null hypothesis is not true. The data provides sufficient evidence to conclude that the average salary in the public sector institutions are higher than the salaries in the no, the salary in the private institutions is higher than the public institution because the sample mean 1 is larger than the sample mean 2. So your conclusion will not this. Your conclusion will be mean 2 is smaller than mean 1. Mean 1 is greater than mean 2. The reason is we have subtracted the x bar 1 and x bar 2. So if x bar 1 is larger than the x bar 2, we have a positive t observed. So in this case, x bar 1 is larger than the x bar 2, so we have a positive t score. So that is an indication that is rejected. If x bar 1 is smaller than x bar 2, we have a negative t observed value. That will be minus 2.39. So will be rejected from the left side. That is an indication that the mean 1 is smaller than mean 2. But in this case, the conclusion is the salaries in the private institutions is larger than the public institutions. Private teachers are getting on the average higher salary as compared to different exist the mean salary of the faculty in the private and the public institution, but the final conclusion will be what will be the salaries in the private institutions on the average is larger than the salaries in the public institution. That's all for PORT test.